Okay, so for A, we know that the line 3y equals 4x equals 12 meets at the x-axis at point A. So for point A, sorry, for point A, we know that the coordinates of y would be 0. And this is because this meets at yx technically means it meets at the x-intercept. So as you can, like it's somewhere here, so as you can see, the y is 0. And to find x, we can actually use this formula by plugging in 0 in y because in point A, the coordinates of y is 0. So with that, we can find the coordinates of point A, which is 3, 0. And for point B, it's technically the same, but this time it meets at the y-axis. So this time it meets at the y-intercept. So in this case, the x would be 0. And we can find y like just how like how we found x in point A, but this time x would be 0. And so we found the coordinates for point B, which is 0, 4. Okay, so for B, find the coordinates of C. So the perpendicular bisector of AB meets the line y equals x at point C. So for this, we need to find the gradient of the lines first. And the gradient is actually y equals x. And we can use back the coordinates in question A, which A equals to, so meaning that the coordinates of A is 3, 0. The coordinates of B is 0, 4. And for that, we can find the gradient by minusing them. And we can find negative 4 over 3. This is the gradient, but we need to, so we can use the formula gradient 1 times the second gradient equals negative 2, negative 1. But this formula only applies if it is a perpendicular one. So since in this case it is, we can plug in the first one to find the second gradient. And you will get 3 over 4. And this is the gradient line of AB, which is perpendicular. Okay, so, and we can actually form the formula by having y equals 4 over 3 over 4x plus c. But now we need to find c. And to find c, we can use the midpoint of these two coordinates. The midpoint is, oh, sorry. The midpoint, oh my God, will be 1.52. And we can plug in this formula like this to find C, which is the y-intercept. And with that, we found C, which is 7 over 8. So in a way, we found our formula, which is y equals 3 over 4 x plus 7 over 8. And now we need to find c. And to find c, we can find x, because now we actually have two formula. One is this and the other one is this. So since y equals y, in a way, x equals 3 over 4 x plus 7 over 8, because y equals y. And now we can find x. So x equals 7, oh sorry. So 7 over 2, which is 3.5. So this is x. And to find y, you can plug in x. Which you'll actually get the same, which is 7 over 2, which is 3.5. So the coordinates for C will be 3.5 and 3.5. And that is B, which is a bit messy. Okay, for C, find the area of the quadrilateral ACB, where C is the origin. Okay, so for this one, we don't really know what the shape is. It could be like this or anything else, but we can actually find the area using like something like a formula called modulus, which goes like this. And you need to write, sorry, and you need to write the coordinates following the order, which is 0, 0, which because 0, the origin means 0, 0. Okay, and then next is 3, 0. Oh, sorry. 3, 0. And after that is -3. Wait, it's not negative, sorry. It's 3.5, 3.5, then 0, 4, and only 0, 0. Okay, we have this shoelace method. It's like times here, multiply like this, and also multiply like that. I'll write it bigger. Okay, this is the first one. This is the points. And you need to rewrite the first coordinate. Then you can start using the shoelace method. So first we multiply bottom like this, where you will get 0 plus -10 over 0.5 plus -14 plus 0. And then we need to multiply it up again, but this time it will be negative. And since everything we multiply is 0, basically we don't need to subtract anything. Okay, so after adding everything up, it will be negative 24.5. And this modulus actually means that anything that's negative will become positive since there's no negative area. So at the end, it will be like this. Cross cross, the answer will be 12.25 units squared. And that is C.